Today we're going to learn to find the solution to a differential equation using a method called separation of variables. The differential equation we are going to start with is dy dt equal to 20 minus y. So we have dy over dt is equal to 20 minus y. We have two variables here, y and t, and the goal is to get all the y's on one side of the equation and all the t's on the other side of the equation. So our first step is to multiply by dt. That gives us dy is equal to 20 minus y, and then I multiply all of that by dt. Next, I bring the 20 minus y over to the other side by dividing. So I have dy divided by 20 minus y is equal to dt. So now our two variables are separated. Next, we're going to integrate both sides. So integrating both sides on the left-hand side gives me the integral of 1 over 20 minus y dy is equal to the integral dt. If you like, you can put a little 1 right there in the integral before the dt to make your life a little bit easier. So now we can integrate. On the left-hand side, you could use u substitution with u equal to 20 minus y, and when you do that, you'll get minus the natural log of the absolute value of 20 minus y as your antiderivative, and on the right-hand side, you just have t plus c. So we integrated, we have y on one side, we have t on the other side. Next, we want to solve for y. So next, solve for y. So to do that, we can multiply by minus 1. That gives us the ln of 20 minus y is equal to minus t plus c. And we need to get to this y right here. And to do that, we can raise e to the left-hand side and to the right-hand side. Oh, and actually I made a small mistake, so let me fix that. When we subtracted, when we multiplied by minus 1 on both sides, that c also became negative. So I need to get to that y. So I take e to the left-hand side and e to the right-hand side. The e and the ln will cancel, and I'm left with the absolute value of 20 minus y is equal to e to the minus t minus c. I can rewrite that as the absolute value of 20 minus y is equal to e to the minus c times e to the minus t using laws of exponents. So both sides, the left and the right, are positive. I won't need to drop the absolute value on the left-hand side to get to that y, and that causes my right-hand side to also become, or I need to allow it to be negative. So I'm going to replace e to the minus c, which is a constant. This is a positive constant. By dropping the absolute value sign, I'm going to replace it with d, which is another constant that can be positive or negative. So d is going to be plus or minus e to the minus c. Now we are almost done. All we need to do at this point is solve for y, and doing that I get y is equal to 20 minus d e to the minus t. So now we see we found y as a function of t. So in this case, y represents the temperature after t minutes of this metal bar. So if we wanted to know what is the temperature after 5 minutes, we could just plug 5 in for t and we get the temperature. But we still have this variable d, or rather it's not a variable, we just have this constant d right there. And so any value of d will give a different solution to our differential equation, depending on initial conditions. So if we have initial condition less than 20, let's say 5, sorry about that, we get something like this. If we have initial condition bigger than 20, we get the temperature decreasing like this. And if we actually have 20, we get something like that.